In this lesson, we are going to talk about some basic operations with whole numbers and decimals. Some of the things that we're going to talk about, just to kind of refresh your memory, there are some symbols that this symbolizes less than, this symbolizes less than or equal to. When it's kind of pointing to the right, it's greater than, and right with the line underneath it is greater than or equal to. So this one is less than, I think of it as, because it points to the left, kind of makes an L-ish. But those are the things that will kind of be incorporated throughout this unit and this chapter potentially specifically. So to start, it says we're going to compare two whole numbers. It says we're going to write two inequalities. These are inequalities. Okay, where equal sign, just a pure equal sign, are equalities. Any of these are inequalities because of the potential less than or the greater than associated with them. So we're going to write two inequalities to compare the pair of numbers. So there's two options to this. Either you got 2800 is bigger than 2500, regardless of what the numbers are after it. So you could either write it as a small number on the left. So 2517 is less than 2802. Or you could be writing it as 2802 is greater than 2517. Either one is acceptable. Okay. Writing fractions with power of 10 denominators. Power of 10 just means 10, 100, 1,000, 10,000, one and a bunch of zeros, basically. So we want to write these as, write the fractions as decimals. So there's two ways to do this. If they weren't 100s on the bottom, I'd say there's really one way to do it. But we're going to talk about that there's actually a shortcut to do it, going about doing this one. But initially, we have a fraction. The biggest thing people have to remember is a fraction is a decimal, or is a fraction is a division problem. So really what this means is 23 divided by 100. So 23 divided by 100. And there's my decimal. So that decimal is 0.23. However, there is absolutely a shortcut to these. So if we want to, if we're going to have some sort of a fraction, and if you have a 10, 100, 1,000, 10,000, and you're dividing by those numbers specifically, then all you're really going to do is you're going to be moving the decimal. So there is kind of a shortcut to this, and these happen more often than you think. And it's a lot faster than actually even typing it into a calculator. So what we're going to do is, if we're dividing by 100,000, so we're going to move the decimal back. We're making it smaller, so we're moving it backwards. The same number of places as zeros. Okay, so let me show you what I mean by that. That means that we're taking the number 23 and we have 100, so there's two zeros. So 23 has a decimal here, and we're going to move it back 1, 2. And that's where our decimal will go, exactly in the same location as where that is. So if we're doing 468, 468, we're moving it, we're dividing by 1,000, which has 3 zeros. So all we're doing is 1, 2, 3, and that's where your decimal goes. 0.468. All right. So could I throw on the calculator? Of course. So 468 divided by 1,000. But we just moved the decimal back 3 spots. Okay. So it doesn't matter, whichever way. Just kind of showing every once in a while that there are some shortcuts potentially with what we got going on. We're going to compare two decimal numbers. So we got two micrometer readings, very, very small, are recorded as 0.837 inches and 0.81 inches. Which one is larger? Well, it's kind of hard to tell initially. So let me just throw the numbers out right now. We're comparing that with that. It's kind of an apples to oranges kind of a comparison right now. If we have 3 decimals here, we really need 3 decimals here. So all I'm going to do is tack on a 0. Anywhere past that, I would be tacking on 0 because it's not changing the value of it. And now we're looking at 837 compared to 810. So then even though the decimal, we're still at decimals, but they're still kind of the same idea. 0.837 would be greater than 0.810. All right. Aluminum sheathing can be purchased in a thickness of 0.04 inches or 0.035 inches. Which sheathing is thicker? So we want to compare 0.04 compared to 0.035. Oh, and the last one says it was writing our answer as an inequality. That's us writing it as an inequality. Okay, so this one I'm just going to circle the larger of the two. It says which sheathing is thicker. So again, I got 3 decimal places here. I really need 3 decimal places here. 40 is bigger than 35. So that one was the thicker of the two. All right. Rounding. Rounding. Don't forget that if you are rounding, we are looking at numbers 5 and up. They round up. And 4 and lower. Round down. Now on the rounding down, really keeps the same. It's really a smaller value, but it keeps the same. You'll see. Okay, so we're going to round 468 to the nearest 100. So if I'm going to do that, I got 468. I always like to underline the place value that we're rounding to and circle the immediate number after it, because the number after it is the number that's dictating whether this thing rounds up or stays the same. All right, so here's my rules. That number is 5 and higher, 5 and up. So then that 6 is gonna round up the 400. Another way to think of it is basically, are we closer to 400 or 500? Well, 468 is closer to 500 than it is 400. But the shortcut of this is 6 makes that go up. So then that becomes 500. All right, and then we have this thing, 8, 2, 6, 2, 9, 4, 0, 4, 2, 6, 0, 2, 1, and we're around into the nearest billion. So we have thousands, millions, billions, and that is the nearest billion. Okay, so the 2, immediate number after it, the 6 is going to round that up. So we have 83 billion. 1, 2, 3. 1, 2, 3. 1, 2. Okay, and that's rounded to the nearest billion. And the last problem, nope, word problems. Add and subtract some whole numbers. So we were looking at a couple word problems. It says how many feet of fencing are needed to enclose the area shown. So we're not talking about the area, we're talking about enclosing the area. All right, so that means that we are looking at perimeter. Now there's formulas for perimeter. Perimeter to me just means what's the length around something. I don't think of formulas, I just add up all sides. So that way I don't have to memorize any formulas for perimeter. It doesn't matter what the shape is, I'm just gonna add all the sides together. So we have sides of 50, we have 100, we have 75, and we have 125. And if I throw that in the calculator, that adds up to 350. All right, so perimeters just add up your sides. If you're a formula person, by all means, look it up, but this is a weird shape. So I don't know where you're gonna go with that, but just add up all your sides. All right, next one. We got a bricklayer lays 1,283 bricks in one day. Second bricklayer lays that many bricks. How many more bricks did the first bricklayer lay? So that person laid this many bricks, second person laid this many bricks. So obviously this one's greater than this one. So how many more? We're always looking at the difference between something like that. So we're looking at 1,283 minus 1,097. And I'm just going to throw that into the calculator, and that's going to give me 186 more bricks. All right. So we're just looking at a difference. And that one's definitely the higher of the two. Okay. Multiplying and dividing. So Bill repaired 6 cars per week. Okay, so that's a rate kind of a thing. So that's important to take into consideration that this is a 6 cars per week kind of a thing over 14 weeks. How many cars did he fix? So every week we were repairing 6 cars. So we're looking at 14 weeks at 6 cars per week. And we multiply that together, and that's going to get us 84 cars. All right. And that covers it for the first section. And then we'll do some more in the next section.